Question 1. Scenario. An analyst wants to write a KQL advanced hunting query to find all instances where a process made an outbound network connection to a specific suspicious IP address, including the process name and command line. The question is, which table should the analyst primarily use? Your options are: Option A, device file events. Option B, device registry events. Option C, device network events. Option D, device logon events. Take a moment to think about your answer. The correct answer is C, device network events. Why C is correct? Device network events captures network connection activity, including the initiating process name, command line, remote IP, and port, making it the correct table for identifying process-to-IP outbound connections. Why A is wrong? Device file events tracks file creation, modification, and deletion, not network connection details. Why B is wrong? Device registry events tracks registry key changes, unrelated to network connection activity. Why D is wrong? Device logon events tracks authentication, logon activity on a device, not outbound network connections. Question 2. Scenario. An analyst wants to identify all sign-in events from Microsoft Entra ID where the user was flagged with a risk level of high, joined with the corresponding device compliance status from Intune, using KQL in Sentinel. The question is, which tables should the analyst use in this KQL query? Your options are: Option A, sign-in logs, or ARD sign-in events beta, joined with a device compliance table, e.g., from Intune Data Connector. Option B, device file events joined with email events. Option C, device process events only. Option D, threat intelligence indicator only. Take a moment to think about your answer. The correct answer is A, sign-in logs, or ARD sign-in events beta, joined with a device compliance table, e.g., from Intune Data Connector. Why A is correct? Sign-in logs, or the Defender XDR equivalent ARD sign-in events beta, contains sign-in risk data, and joining it with device compliance data provides the combined view of risky sign-ins correlated with device compliance status. Why B is wrong? Device file events and email events track file and email activity respectively, not sign-in risk or device compliance. Why C is wrong? Device process events tracks process execution, unrelated to sign-in risk or Intune compliance data. Why D is wrong? Threat intelligence indicator contains IOC data, not sign-in or device compliance information. Question 3. Scenario. An analyst needs to find all emails that had a URL later found to be malicious, clicked by users after delivery, a scenario relevant to zero-hour auto-purge, across Microsoft 365. The question is, which tables in advanced hunting are most relevant? Your options are: Option A, device network events only. Option B, identity logon events only. Option C, alert evidence only. Option D, email events joined with URL-click events. Take a moment to think about your answer. The correct answer is D, email events joined with URL-click events. Why D is correct? Email events contains information about delivered emails, while URL-click events records safe links click events with their time of click verdict. Joining these two tables identifies which malicious URLs were actually clicked by users. Why A is wrong? Device network events tracks device-level network connections, not email delivery or URL click events specifically. Why B is wrong? Identity logon events tracks on-premises AD authentication events, via Defender for Identity, unrelated to email URL clicks. Why C is wrong? Alert evidence contains entities tied to specific alerts, but is not the primary source for correlating email delivery with click events broadly. Question 4. Scenario. An analyst is building a KQL query to identify processes that were created with an unusually long, base 64 encoded PowerShell command line, a common obfuscation technique. The question is, which table and general approach should the analyst use? Your options are: Option A, device logon events, filtering on logon type. Option B, device process events, filtering process command line for patterns like ENC, or from base 64 string, and using string length functions. Option C, device file events, filtering on file name only. Option D, email attachment info, filtering on file extension. Take a moment to think about your answer. The correct answer is B, device process events, filtering process command line for patterns like ENC, or from base 64 string, and using string length functions. Why B is correct? Device process events contains the process command line field, which analysts can filter for known PowerShell obfuscation indicators, like ENC, or from base 64 string, combined with string length checks to detect encoded command line obfuscation. Why A is wrong? Device logon events tracks authentication events, not process command line content. Why C is wrong? Device file events tracks file system operations. Filtering only on file name would miss command line based obfuscation entirely. Why D is wrong? Email attachment info tracks email attachment metadata, unrelated to endpoint process command line analysis. Question 5. Scenario: a Microsoft Defender XDR threat analytics report on a newly identified ransomware group includes a section with pre-built hunting queries specific to that threat. The question is, what is the best use of this threat analytics content for the SOC? Your options are: Option A, ignore it since threat analytics reports are purely informational and contain no actionable queries. Option B, rewrite all queries from scratch instead of using the provided ones. Option C, run the provided hunting queries against the environment to proactively check for related indicators or techniques used by that specific threat actor. Option D, delete the report after reading the summary. Take a moment to think about your answer. The correct answer is C. Run the provided hunting queries against the environment to proactively check for related indicators or techniques used by that specific threat actor. Why C is correct? Threat analytics reports include curated, ready-to-run hunting queries tailored to the specific threat actor's known techniques and IOCs, allowing SOC analysts to proactively hunt for related activity in their own environment. Why A is wrong? Threat analytics reports include both intelligence context and directly actionable, pre-built hunting queries, not just narrative information. Why B is wrong? Rewriting queries from scratch wastes analyst time when Microsoft curated, tested queries relevant to the specific threat are already provided. Why D is wrong? Discarding the report loses valuable ongoing reference material for detection and related indicators. Question 6. Scenario: during an incident investigation, an analyst runs an advanced hunting query and wants to visualize how a suspicious process on one device relates to a file it created, a registry key it modified, and a remote IP it contacted, all as a connected graph. The question is, what should the analyst use to view these entities and their relationships visually? Your options are: Option A, the hunting graph, generated from advanced hunting query results. Option B, a Sentinel workbook pie chart. Option C, the Azure Cost Management View. Option D, the Threat Intelligence Indicator Expiration Report. Take a moment to think about your answer. The correct answer is A, the hunting graph, generated from advanced hunting query results. Why A is correct? The hunting graph visualizes entities returned by an advanced hunting query, processes, files, registry keys, IPs, etc., and their relationships as a connected graph, helping analysts understand attack blast radius and entity connections at a glance. Why B is wrong. A pie chart in a workbook shows aggregate statistics, not entity relationship connections. Why C is wrong. Cost management tracks Azure spending, entirely unrelated to visualizing entity relationships. Why D is wrong. The indicator expiration report tracks threat intelligence freshness, not query result entity relationships. Question 7. Scenario. An analyst wants to determine the full blast radius of a compromised device by visualizing all other devices, users, and cloud resources it has interacted with over the past 7 days, to identify potential lateral movement targets. The question is, which feature is specifically designed to support this kind of investigation? Your options are: Option A, the Vulnerability Management Dashboard. Option B, the Azure Policy Compliance Dashboard. Option C, the DLP Policy Match Report. Option D, the Hunting Graph, Sentinel Graph, expanding entity relationships from the compromised device. Take a moment to think about your answer. The correct answer is D, the Hunting Graph, Sentinel Graph, expanding entity relationships from the compromised device. Why D is correct. The Hunting Graph, Sentinel Graph, is purpose-built to expand and visualize relationships between entities, letting analysts trace a compromised device's connections outward to other devices, users, and resources to assess blast radius and lateral movement potential. Why A is wrong. The Vulnerability Management Dashboard shows software weaknesses and exposure, not entity relationship blast radius. Why B is wrong. The Azure Policy Compliance Dashboard tracks resource configuration compliance, unrelated to entity relationship analysis. Why C is wrong. DLP Policy Match reports show data loss prevention triggers, not device-to-device or device-to-user relationship mapping. Question 8. Scenario. An analyst runs an advanced hunting query that returns 500 rows representing distinct entities, devices, users, IPs, and wants to explore how these entities are interconnected without manually cross-referencing each row. The question is, what is the recommended next step in Microsoft Defender XDR? Your options are: Option A, export to Excel and manually build a diagram. Option B, select the query results and generate a hunting graph directly from the advanced hunting interface. Option C, delete the query results and start over with a narrower query. Option D, convert the query into an ASA rule. Take a moment to think about your answer. The correct answer is B, select the query results and generate a hunting graph directly from the advanced hunting interface. Why B is correct. Advanced hunting in Defender XDR allows analysts to select relevant query results and generate a hunting graph directly, automatically visualizing entity relationships without manual cross-referencing. Why A is wrong. Manually building a diagram in Excel is time-consuming and error-prone compared to the native, automated hunting graph feature. Why C is wrong. Starting over with a narrower query loses the broader dataset that could reveal important relationships across all 500 entities. Why D is wrong. Converting a hunting query into an ASA rule is not a valid operation. ASA rules are predefined attack surface reduction behaviors, not custom hunting queries. Question 9. Scenario. An analyst wants to identify which specific MITRE ATT and CK technique corresponds to a detected, pass the hash, style lateral movement activity observed in advanced hunting results, to properly tag the finding in their incident report. The question is, where should the analyst look to confirm the correct technique mapping? Your options are: Option A, the Azure Cost Management Report. Option B, the DLP Policy Configuration. Option C, the Alert, Detection details showing associated MITRE ATT and CK technique IDs, cross-referenced with the MITRE ATT and CK framework. Option D, the device compliance policy list. Take a moment to think about your answer. The correct answer is C, the alert, detection details showing associated MITRE ATT and CK technique IDs, cross-referenced with the MITRE ATT and CK framework. Why C is correct? Detections and alerts in Defender XDR and Sentinel are commonly tagged with their associated MITRE ATT and CK technique IDs. Cross-referencing this tag with the official MITRE ATT and CK framework confirms the correct technique for accurate incident reporting. Why A is wrong? Cost management tracks spending, entirely unrelated to MITRE ATT and CK technique mapping. Why B is wrong? DLP policy configuration concerns data loss prevention rules, not technique classification. Why D is wrong? Device compliance policy lists track in tune compliance state, unrelated to ATT and CK technique identification. Question 10. Scenario. An analyst is unsure whether a specific KQL table, identity logon events, contains cloud-based Entra ID sign-ins or on-premises Active Directory authentication events for a hunting query they are building. The question is, what is accurate about the identity logon events table? Your options are: Option A, it contains on-premises Active Directory authentication events collected via Microsoft Defender for Identity. Option B, it contains only Azure Resource Manager deployment logs. Option C, it contains only Microsoft Teams chat messages. Option D, it contains only DLP policy match events. Take a moment to think about your answer. The correct answer is A. It contains on-premises Active Directory authentication events collected via Microsoft Defender for Identity. Why A is correct? Identity logon events captures on-premises Active Directory authentication activity gathered through Microsoft Defender for Identity sensors, distinct from cloud sign-ins which are found in sign-in logs, ARD sign-in events beta. Why B is wrong? Azure Resource Manager deployment logs are found in the Azure Activity Table, not identity logon events. Why C is wrong? Teams chat messages are not captured in identity logon events. This table is specific to authentication events. Why D is wrong? DLP policy match events are found in tables related to Purview DLP, not in identity logon events. Quiz complete. You have reviewed all questions and their full explanations. Great work. Please like and subscribe my channel for more such contents.